It's Monday. I hope all of you are as caffeinated as I am. Salutations, class, and welcome back. Tonight we have a very, very important evening. This is the first instance that we'll actually be getting into a formal lesson from Professor on just how to be doing the whole programming thing. With the name of Turing, it's something I should have done a long time ago. We'll be going through some of the basics in Game Maker Studio 2, mostly over variables and collisions as we make a little bit of a starter for a platformer engine. I'll be answering any questions at all, so please do ask me, and I'll go ahead and see how we can solve whatever issues that might come up. I already have Game Maker Studio 2 open over here. Not much that we've done so far. Went ahead and made a couple of basic rectangles. I am by no means a graphical artist, so we'll mostly be starting out with a bunch of simple rectangles here and there to signify the objects that we'll be working with. This is usually referred to as gray boxing. A lot of level design for more formal video games that you see will not end up having very complex assets to begin with. In fact, to test a lot of their platforming movement challenges and level design, they'll usually create just simple. It's called gray boxing because they'll just use plain gray collision boxes here and there for you to interact with your character, and after they get a level that feels right, then we'll work on the graphics. So, starting out with, we only need two basic things to start with for a platformer. We need the walls for a character to collide with, and an object character over here on the right. You'll see that I guess that's zoomed in enough. I don't know if you can read the names of our text on the side here. There might be an issue with the resolution. Hopefully everything should be legible. So, we have our character object here, and we're going to go ahead and start assigning him some variables, which is how you manipulate the game and keep track of what sort of things change with your character. Since we are a platformer, there are a number of different things that we'll need to be keeping track of. Welcome, ETG! And actually, I suppose before we start typing up, I should give everyone a formal welcome here. ETG, Kayla, Siphon, Broham. I do believe Decursion was in here earlier, but I didn't. Yeah, it's not showing up here in OBS. So to start with, we'll need to think about what we're doing with a platformer character. Platformer characters will generally move side to side and have gravity to deal with. So, we'll start by assigning some basic variables of, let's see, movement speed. We'll go ahead and assign. Can we zoom in? Ah, that's much better. Much better. Natsume and James, both of you welcome. Let's see, what's readable here? There, that should be plenty readable right there. So, movement speed equals, let's go with a simple number like 5. We'll be placing the semicolon there mostly as a courtesy, which is common in most C derivative languages, which Game Maker Studio's language is most similar to. It's kind of like C. Movement speed, we'll be using this as a cap on the speed that our character can go horizontally. Then we'll also need a gravity variable. From most of my playtesting, it usually comes to about 7.5 is a good number for us to start with. And we'll be playing with raising and lowering this variable to get the right feel. Most important thing about platformers is making them feel right. Your character needs to have a proper weight. Not be too slow, too fast, too floaty, or too heavy. So we'll be playing with these numbers as things go on. Now, that's a simple thing to start with, but we'll also need a couple of variables to track the actual condition of what. Oh, great. Of course. Well, that's certainly a departure from the boss that we've usually had. Block user on YouTube. I guess I should, If that's the case, then while we're at it, I might set the stream to subscribers only. Wow. That's definitely the worst one we started with. minimum subscribe time, 1 minute. What a weird bot. Ah, I guess we will have to deal with more malice here in the future. So, the warning symbol here, this is because we have not yet used the variable. These will go away in time as we start implementing other things. Says here, variable move speed only referenced once, which we'll be getting to in time. Usually you don't want to allocate the memory for variables that you aren't going to use. That's just extra space you're taking up in memory. But we'll be using these soon enough. So, these are the constants that we have for our character, which we might want to notate. Go ahead and label these as our constants. These are numbers we will not be changing, but will be specific to this character object that we'll be using to manipulate our other variables. So down here we'll use, these are the important variables that we'll get to. Let's see, we will want to check if we are grounded or not. So grounded equals, let's say, false. So our character can start out recognizing if they're on the ground or not. That's what this variable will notate, if we're currently in the air or not. And we initialize it to false. This is a Boolean variable, so really, we only want to test if we're currently on the ground or not on the ground. And we'll use this to manipulate our gravity. This is a Boolean, so we're only going to worry about changing it to true or false. In other words, a yes or no, measuring if we are currently on the ground. Facing, this is important, and we don't necessarily need to use this yet. But what we'll do here is we'll have a facing variable which determines if our character is facing left or right. And this one, even though it might be usable in a Boolean state, will be manipulating a lot of other math with it. So in this case, we'll set it to 1. Always comment your code so that you can know what you're doing when you come back to look at it later. So the reason we're setting this to 1 is we want to use it for 1 if facing right, which facing right is generally a universal standard among video games. In fighting games, the player starts out facing right if you're on the player 1 side. In 90% of all video games that you'll play, if it's a two-dimensional game, you'll be facing towards the right on very first level or whatever other things. It's just a standard we adopted long ago. In this case, though, even though we're really only going to know if we're facing right or left, we'll be, interestingly enough, doing a lot of math involving if we're facing the other direction. In this case, we'll do -1 if facing left, and I'll be showing you why we're doing that later on. Welcome, So Chill. Hope you'll be able to learn something today. And be sure to ask questions if you have any questions at all. Let's see, we have a grounded variable and a facing variable. Is there anything else we need? Ah, right. So, another constant we'll need. We need a friction variable. Right, friction is an internal variable held by GameMaker, so you'll see that the text here is highlighted in green. That means that this is an internal variable handled by GameMaker, and we don't like how GameMaker handles all the stuff automatically. So in this case, we'll call it horizontal friction with an H. That should change to blue here in a moment. There we go. Let's say 0.5. So you know objects always have some level of friction. If you're moving left or right, you want your character to slow down once you release the key, right? Otherwise, the instant we release our keys, we're going to keep going. Objects at rest stay at rest, and objects in motion stay at motion, unless acted upon by another force. Funny enough. Well, actually, no. I'll introduce that here in a moment. In fact, we might not even need to use friction just yet before I demonstrate you the basics here. Now we'll need a horizontal speed variable and a vertical speed variable. Now, GameMaker does have its internal variables to measure horizontal speed, which is the full h speed here, and v speed, but we want to manipulate all of our variables as much as possible on our end. V speed and H speed actually have automatic functions that happen in GameMaker Studio. And because we're smarter than that, we're going to manipulate things according to our own interests. So, these are the variables that we initialize on our character. Moving over here, you see this is our create event. So, the create event is what happens when an object is first created in GameMaker. Description. Let's go ahead and change that to initialize variables. So when our little character is created, we'll go ahead and assign all these variables in memory, and this will happen for every character that we create. Now, that is what happens when our object is created, but we need them to actually act in the game. So here we will go to the step event, and here we'll go ahead and just say happens. It's kind of funny not seeing my keyboard past my microphone. Every frame. I think we've had a couple of messages. Yeah, let's go ahead and move this back up here. So, the step event in GameMaker is something that happens every single frame of your game, and I believe most games are in 60 frames per second, right? Let's see here. I don't think we'll have to worry about the frames per second just yet. I might need to look that up. I think GameMaker actually starts with a 30 frames per second rather than 60. And the nuances of that we're not quite worried about yet. And I'll show you how we can manipulate that soon enough. So, step. What are we doing every frame? Well, we're checking our current movement, and we're going to have to check if there's something below us to determine if we are currently on the ground or not. There's a number of functions we have for this. So, let's go ahead and start every frame with... We'll want to start by looking if there's something below us to see if there's an object. So, very first thing we're doing here is there an object below? This will use, I believe it's place meeting. I haven't programmed in GameMaker Studio in here in a while. Place meeting, if we zoom out, we might have... There we go. GameMaker Studio is very kind and polite to us, and it shows us here the functions and what sort of variables we need to assign in what order for said functions. So, we're looking for if there's an object at the spot in our x variable, which is where we are on the screen. You'll see that the x here is green, and that's actually an internal variable handled by GameMaker Studio that we'll let them use, because all the automatic functions that handles with really only determines where an object is on screen, and it doesn't have anything that automatically happens in the background. So at the x where we are, and then y, as usual, is what you'd expect for a 2D thing. But we're not checking where we are checking below us. And in GameMaker, plus sends you down or right, depending if you are on the vertical or horizontal axis. Negative values send you up or left. Good evening, heroes, and welcome. So, what this means right here is we are checking where we are, and then 1 pixel below us. And then we'll go ahead and check if our... You'll see here on the right of the screen, object wall. There we go. And that text will be highlighted in red because it is an asset we have in here. Already see yourself watching this stream so many times. That's why I'm doing a live stream. If you have any questions, and if I'm going too fast, please tell me if I need to slow down or if you need something explained. So, this here is an if statement, which is generally pretty intuitive. It's if something is true, so this should generally be human readable. That's the entire point of programming languages, is for you to be able to look at something and be able to tell what it means. So if there is something 1 pixel below us, if there's an object wall here, then we'll execute this block of code here. Else, then we'll do something here. This is basically how you handle a lot of toggles in games. This is called an if-else statement. So if something is true, then we do this. Otherwise, we do this. So right here is what we're doing if there is something below us, or if we are in the air. This first block right here. Now, really what we'll need to do here is set grounded to true, which is how we track if we're on the ground or not. Simple enough. Then we'll go ahead and space things out over here. Yeah, that'll do it. Right. I should make a channel in the Discord and go ahead and leave spots for people to ask about programming stuff. See if I can help with anyone's basic issues. I'll do that. That's a wonderful idea, Kayla. Thank you. So, grounded is true. And if we are grounded, we will want to set our vertical speed to 0 so that we don't fall through the floor. Now, if we are in the air, then grounded is false. And then we'll go ahead and say VSP plus equals grav. Now, to explain this, if we are in the air, then we set a grounded variable which tracks if we're on the ground or not to say, no, we are not on the ground. What this means is vertical speed, which is our vertical speed value. The reason why I have it shorted into VSP is we are going to end up typing this a lot. So we want to have something brief, only 3 letters here, that we can generally read what it's supposed to mean. So vertical speed plus equals. Now the equal symbol here is important. In most programming languages, that means we are setting something. This is roughly equivalent to a period when you are writing out a sentence. If we just do VSP plus grav, there we go. There's an error. Unnecessary expression VSP used as a statement. So if it's just a plus here, like how we have here in place meeting, this usually is part of an expression to test. If there is no equal sign, then essentially you are writing a sentence without a period, so you can't really read where it stops, or if it's a question or a statement. That's what the equal sign here is for. The plus equals here is an operator that means that we are going to take this and add whatever follows to this. Vertical speed plus whatever statement is here. So what this means is our vertical speed, if we are in the air, is constantly going to add our gravity to it. Now, we do have our motion here, right? But we are going to need... That's what we do for our vertical motion testing. We're going to need to actually check with collisions based on our speed. I think we can go ahead and at least test out our jumping here, right? Right! We don't even have a function to make us jump. Do we want to handle that at the beginning or the end? I think it might actually be proper to begin our step with interpreting all of our button inputs. So, here, we're actually going to go ahead and test for inputs here. This is where we'll be doing the inputs. And since I don't have my controller plugged in right now, we'll go ahead and start with keyboard stuff. I'm going to do a lot of talking, so there might be a good time to pause every so often, take a drink. After all, this is going to be a very, very chatty stream. And the tea is still scalding hot, no matter how much ice I put in it. So, we need to test if there's input coming in from the keyboard. So, if, let's see, what was it in Game Maker? I think it was, alright, keyboard check. We also have keyboard check direct, keyboard check pressed, which is for when we first press a key, and then keyboard check release, which is for when we stop pressing a key. Right now, we're only testing if a key is held down, which we can use keyboard check for. What language? Well, Decursion, we are doing this in Game Maker Studio, which has its own language, which is, you know what? Why not write it in here? Let's see, get me another text box. Python. Alright, good language to start with. So what we are doing... Come on, give me my text. And we'll set this to a size, let's say 80. Outline, as always. Outline needs to be, what's the usual standard here? Black outline, white text. That's what we always do. So we are working in Game Maker language, which is mostly derivative from C, which is one of the most common standards. Most of the games that you play, if they're from a big AAA studio, will be in C++. Those of you who have any experience with game programming languages will have heard of it. There's also C Sharp, which is a somewhat simpler derivative of C++. C++ here is the big boy that you'll see a lot of the bigger studios use. But we also have the most common language to teach with. A lot of beginner language courses will be here in Python, which is somewhat comparable to C, but has a lot of the rules taken out. C is personally one of my absolute favorites, and that is what is most comparable to Game Maker language here. So, there's a lot of things that you might be able to transfer to Python, but there's a lot more standards in GML. In this case, you do actually have to notate these curly braces here, which these denote when you have an if-else statement begin or end. If I remember from my Python days, you just tab over in Python, which is a good standard, but you see standard, but it throws us an error here. So we're going to put those back. So if keyboard check, let's see, keyboard key. So this is green, and it is an internal variable held by Game Maker language. You can't just say if keyboard check, let's say W. This should throw us an error. Yeah, it'll throw us a warning because it believes W here is a variable. That's mostly how we're typing out all of our variables here, is just the word itself. So keyboard check, and then we'll need to pass it an ID, which Game Maker Studio internally recognizes. This is what we use keyboard key for. And if I remember, it tests for a character, right? No, it does not. So is it W? Right, it might even be in quotes. You know, before we start having errors show up, this is where we get to It's not installed. Yeah, fine. Use online manual. Go ahead and bring this out and bring this over here. So, If you are a little out of the loop like me, I haven't programmed in Game Maker Studio in a couple of months, so some of the basics I might be a little out of the loop on. But don't be afraid to look up something if you don't know it. A joke commonly practiced among programmers is looking at the documentation left and right. This is actually why commenting on your code is important, because you will come back to this and you will not understand what is written sometime in the future. I guarantee it. So always take notes, always write comments on the code that you are writing here. Now, we're going to look for keyboard and all the stuff that comes with it. Over here on the left, let's see here. Keyboard shortcuts. They changed the help manual since I last looked here. All right. So we're messing with keyboard key. There we go. There we go. Okay, we were still on the old page. With this variable, you can get the key code of the key that is currently being pressed, and it will turn 0 if no key is being pressed when the check is done. Wait, no, I had it completely wrong. We're actually using the wrong variables here. So, get this out right now, because what that does is it only checks the current key being pressed. Let's go ahead and take a look here. That's what it was. They changed it to ORD in a later update. So here in the documentation, we have a good example for us to look back at here. And you see we're going to end up writing a very similar text block to this. If keyboard check, so the keyboard check here means if we're testing the keyboard and if ORD A is pressed. ORD right here is a shortcut for keyboard, as you can guess. And then we use a string A to notate which ORD we're checking for. So, keyboard check, and since we are going to use WASD, we're going to basically do the same thing. ORD, and you see here on the function it has ORD character, which it will test for. Put something here in the parentheses. So, the way these functions work is it should be relatively intuitive. You have a function here. Functions are notated in the orange text. And then you'll need to tell the computer to look inside the parentheses paired with it. Luckily, the IDE for Game Maker Studio tells us which parentheses are in brackets here, the two highlighted in blue. So inside of this function, we are using another function, ORD, which we will check for A. Talk slower and explain more. All right. Go ahead and take a break here. You know what? Since my tea is scalding hot, I think I will go ahead and see if I can get some more ice for that, because that is still scalding my tongue. Welcome, A-Joy. Good morning to you. I will go ahead and grab a drink and be right back. There we go. Some more ice should make that a bit more palatable. Respecting the developer more. This is just the basics, so chill. So, we have a lot more to get here soon. And welcome, A-Joy. We haven't gotten to anything big just yet. So, let's go ahead and slow things down a little bit for Kayla here. And because I am sort of speaking quickly here in the first place. So, if, which is kind of a special function, it's used in just about everything. So, this one doesn't have brackets. It's part of a lot of internal testing. And it just means we're checking for something. If, and then we test for a function. Keyboard check. What the keyboard check here does, and let me open up my help here again. And we'll read off this together. When dealing with the keyboard in GameMaker Studio 2, you have a variety of functions that can be used to recognize different keyboard states, like if it's pressed or released. There are also some that store all the key presses as a string, or can tell you what the last key pressed was, as well as others that allow you to clear the keyboard state completely. Blah, 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 blah. Let's get down to keyboard check that we're looking for specifically here. With this function, you can check to see if a key. What keyboard check does is we are checking for a specific key, if it is held down or not. So what keyboard check here does is if whatever is in this little function here is true, if that keyboard is held down, then the if statement here will be true. And we'll go ahead and put the little brackets there. We don't need an else on this statement, as we're not going to necessarily check if A is sort of a toggle, which is what you'd use the else stuff for. We might actually be able to use that in the keyboard check here in a moment. So, if keyboard check, ORD A. What this is, let's go ahead and go back. We should have an ORD function in here, right? No, we don't have it in here. So we'll go over here. And we'll look up what the ORD function does. So what ORD does is it gets the Unicode for whatever keyboard we're checking for. This is what we'll use to check for numbers or keys on the keyboard. So the code here in GameMaker doesn't directly read, say, you can't just put in A or spacebar and stuff like that. Computers are very, very stupid, and they need a list of things to look up. So when you check for an A, you don't actually tell the computer to check A. You tell it to look at a table of characters for it to look up. So let's go to Unicode. Let's see, do we have a Unicode table? All of the characters here on the computer are actually handled as a series of numbers. Let's go ahead and look for a Unicode table. Yeah, there we go. So you have to tell the computer to look up its registry of different characters. Now, here we have a table, and it might be a little difficult to read exactly what it means. But here we have a list of the numbers and letters for what corresponds to each key here. Say, for A example, this is Unicode 0041. And this is 61. A computer does not recognize the letters, but mostly just has... You've seen the whole binary thing. There's a lot of internal numbers that the computer handles. It actually doesn't read letters, but it reads groups of numbers. So we have a table here that's sort of like a cipher. So this here is at the intersection of 40 and 1. Unicode 0041 corresponds to a capital A, and then 0042 corresponds to a capital B. So actually, if you knew that table by heart, you could say 0041, and this would actually check for an A. We need an ORD function here, which sort of parses it to make it more readable to a human. So ORD. What this does is it looks for whatever string we input and then finds whatever the Unicode is. Yeah, returns the Unicode UTF-8 value, which is all of these. So, we feed in ord A, and what ord does is it says, okay, you input A here. So I'm going to change this A into whatever we have on the Unicode table, which means that what we see here is keyboard check ord A, but what the computer sees is keyboard check 041. So that's what the ord shortcut does here. It changes what we input into a number recognizable by the computer. So what this does here, if A key is held down, and we do test it with capitalized, right? Well, we check here on the documentation and it tells us. Note that when used with the keyboard check functions, the input string can only be one character in length and can only be a number from 0 to 9 or a capitalized Roman character from A to Z. So, we have the input here correct. So, if we're holding down A, then we'll want to add to our horizontal speed. And what was our variable again? You know what, we'll go ahead and use H friction. What this does is it will accelerate or decelerate our character. You play any platform and they do not immediately reach top speed. This is important because it is helpful for getting a character to feel right, rather than the basic boring function of setting something immediately to top speed. Right, no. We want to do minus equals. So, as I told you, minus corresponds to left on the x-axis and upward on the y-axis. So what we are doing here, keyboard check A, most of you computer gamers will understand that WASD on the keyboard is how most games do their inputs these days. A corresponding to left, W to up, S to down, and D to right. So this is basically if we are moving left, then we want to subtract our friction from our horizontal speed. And what this does is it adds to our speed going left, which is what the minus here is for. It makes our speed negative, which a negative speed will move left. A positive speed will move right. So we'll go ahead and copy this block here and do the same thing for if we're going right. In this case, we'll be checking for D and then adding to our horizontal speed. This here is a very simple check here of if we're holding A, we go left. If we're holding D, we go right. Now we want to check for jumping. So, if keyboard check. Now, there's two ways we can do this. Keyboard check here checks if a key is held down. But we don't want a character to keep jumping if we just hold down the jump button. Funny enough, that's actually how things work in fighting games. But in every platformer, you want to be able to manipulate your aerial mobility. And the way most games do that is by checking how long you hold down the button. So to test if we want to jump, we don't check if the key is held down. But when you first press it. That way, if you're holding down a key, you don't immediately jump once you hit the ground again. So, keyboard check pressed, and we are checking for a key here. Again, ord function, not orb. Keyboard check, ord. And in this case, we'll go ahead and do W. Now, we'll work on putting in other variables and functions here to change the keyboard check, and that's part of making configurable controls later. Right now, we're getting to the very start of getting the platformer operational. So, if keyboard is pressed, that's phase 1. Will there be a double jump? We can implement it, and I will show you how to do that. Exactly, Siphon. And after we get past a bunch of the basics, we can actually work on fiddling with a lot of little things. This is not necessarily an official game that we're making here, but we are working with an engine, and I will show you how to do various little things. And I'm actually glad that you asked the question right there. So, double jumping. When do we test if we can jump? We can't jump if we're floating. We can only jump if we're on the ground and have a surface to jump off of. And later in the air when we do implement a double jump. So this isn't the only check we're doing. If W is pressed and grounded equals true. No semicolon there because this is a question. So you'll notice we only used an equals sign here, rather than a plus or minus. That's because these are operators that change a value. Equals is sort of like asking a question instead. In fact, I'm actually not being accurate here. In Python and in GameMaker language, you can just leave a single equal sign here. But the actual formal thing to do is equals equals, which is how it is tested for in C, or C++, or C#. What equals equals does is it is not a statement, but it is a question. And programming languages just have a lot of these different operators to check. Generally, you'll see equals paired with some other character. Like division would be divided by equals, or asterisk equals for multiplication. What equals equals means equals equals means is equal to, and sort of formatted as a question. So what this little block means is if our grounded is true, if we are on the ground. And these together just combined mean if we press, keyword here is press. Not if W is held down, but if it is not held down and then we tap it. And we are on the ground. Now we'll go ahead and execute the blocks here. So the comments here in green, these are not actually read by the computer at all. These are for us. It really doesn't matter where we put a comment, just as long as it's after whatever code is on a line. If we do the / here, then anything we type afterwards is immediately registered as a comment. You can't put a comment in the middle of a line because that just overrides the rest of the line afterwards. So comments have to be left at the end of whatever code you're writing. In this case, we'll go ahead and say, since we are wanting to jump, that's one variable we haven't yet assigned yet. So another constant we'll want is jump speed. And let's just pick some arbitrary number like -10. Again, negative means going up or going left. In this case, we want a negative value because this is the jump power that we'll have going up off the ground. VSP equals. A single equal sign means we set something to exactly the value on the other side. You've seen us use the plus equals 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 and stuff like that. But here that we did in the create event, we are setting exact values. And again, we'll do that here. Since if we're on the ground, our character's vertical speed should be 0, we shouldn't need to add or adjust. We are wanting to exactly jump the amount that we set here. Equals jump speed. And that's pretty straightforward. If we press and we're on the ground, then we immediately change our vertical speed to whatever our speed is supposed to be when we're jumping. So, we have some basic checks here. If there's a platform below us, or if we're in the air. Here we have our input testing and our jumping. Moving left, moving right, jumping, checking if there's something below, and checking if we are on the air. There's one more thing we need to handle before we actually boot up the game the first time. And this is the important second half and the meaty part of the lesson. Before we proceed, does anyone have questions on either of these two blocks here? For testing our input and getting our gravity to work. Right here, this whole section is gravity. And right here's input. I'll go ahead and take a drink while I wait if there's any other questions that we have for this little section right here. Much better. No questions? Then we'll proceed to the meat and bones. Everything here is easy. I'm about to write some code that's a bit of a next step up. And we're going to be doing something similar to place meeting here. This part I will try to go as slow as possible, as what we are doing now is collisions. This is basically the other important part of the basics behind everything going on in a game. Games are always going to be looking for variables and constants that you're manipulating. And for just about everything else, you're going to need to test collisions if you have objects moving around. And collisions don't necessarily mean objects colliding with each other, but this also accounts for testing positions. We can use very similar code here for, say, if we have a character jumping around and stopping at walls, versus, for example, inscription, hello error. Thank you for the reminder. We don't necessarily work with collisions in a game like that where we're moving around cards, but we do need to test where we are placing objects, say for when we grab a card with our mouse and place it down somewhere. Even if they're not necessarily colliding with objects, we need to manipulate their positions. And we're going to do both at once here. Here we are doing collisions and position manipulation. This is where we actually use the variables that we've set up. So you see that we have HSP and VSP, standing for horizontal speed and vertical speed. We have those variables being set, but we're not actually doing anything with them yet. That's what we do here. If. How do we check? Let's start simple. If place. No. First, actually, we want to check. If horizontal speed is less than 0. And this one's pretty intuitive here. It's just a less than. So we'll go ahead and get another bracket in here. Now, inside of this test, we're going to test with more functions. If. We're doing another if inside of this if. And you'll end up getting a lot of these as you make more and more complex code. If place meeting here's this function again. X minus HSP. So again, if our horizontal speed is negative, right, no, hold on. Let me actually change that here. So, if our horizontal speed is less than 0, then we check at x plus our horizontal speed. Since our horizontal speed here is negative, since we're moving left, this essentially means if there is something to the left of us equivalent to our horizontal speed. The reason why we're using plus here is horizontal speed in this case will be negative. So when we add it to x, it will check a negative value compared to our x because horizontal speed is negative. Because there's a plus here, it doesn't mean we necessarily have something going to the right. It means we are adding it to whatever our variable here is. And if you add a negative to a number, you are essentially subtracting, which is why we're using a plus here and not a minus, because the horizontal speed here is negative. If we subtracted a negative, it would actually be positive, and we'd be checking to the right. So, if there's something in accordance to our horizontal speed, and roughly on the same y variable, and again we're going to check for a wall here, then we'll go ahead and say HSP equals 0. Put the end bracket there, put the other end bracket here. Now what this block means altogether is, if we are moving left, if our horizontal speed is negative, oh, right, I forgot a parenthesis. Luckily, our IDE will throw us those variables as it looks at this code. If we are moving left, and if there is a wall to our left determined by our speed. So we're looking to the distance that we're currently moving. A game operates in most cases, 60 frames per second. So if we're moving, say, 5 pixels to the left, we don't check 1 pixel to our left. We check 5 pixels. We check our speed. Because what we are testing is we're going to move over 5 pixels this frame. So we look if that exact spot is free for us to move into, if it is currently unoccupied by a wall. And that's why the HSP here is being tested for. If there is a wall in the space that we will move to, then we set our speed to 0, meaning we're no longer moving horizontally. Now, we'll do the same thing here for moving right. If we are moving right, and in this case, we check if horizontal speed is moving right. One of the things you want to do with your code is have it run through as few lines as possible, which is why we have these initial if statements here. We are only checking if we are moving left or if we are moving right. And if we're standing still, then we don't have to worry about these collisions whatsoever. So, this little block here, since we are testing by adding our horizontal speed to our x, we don't need to change this line at all. If the wall to our right, we're checking that determined by our speed. This also does not need to change. So we set horizontal speed to 0 here. All this block does is if we're moving right and there is a wall where we're supposed to be, then we set our speed to 0 and stop moving. Now, we've handled our horizontal collisions. we'll need to do this one more time with vertical collisions. And if we were in a three-dimensional plane, we'd have to do it for the third spatial axis. But we're working with a two-dimensional game here. If we are moving up, or if we are moving down. Oh, down. So we're checking for vertical speed here. If place meeting. We're not checking for x here. We're actually checking for something on our y-axis. So instead of adding our horizontal speed to our x, we're going to add our vertical speed to our y. And this checks the vertical position we're supposed to move into next. Basically, we can just manipulate it the same way in both these cases here. Make the x normal and then y plus our vertical speed. Oh, those need to be lowercase. Variables are case sensitive, and it's a general programming rule to put variables in lowercase. The first letter has to be lowercase, but you can have uppercase later. Say if you wanted to write your variable out like this. Welcome, 0. Are you saying you can't read the text on screen, or you're illiterate in general? Which might mean that programming would be out of your field of expertise. All right. So, we have our basics here. This should be our first chance to test our game. We check for our inputs, we check for our gravity, and then we check our collisions. I actually left out one last thing. So that is our collision detection. But now, the very last thing we do. All of this, you see, here we have if. All of our testing for this frame is done. Our character object will be moving through every single line of this, every single frame, 60 frames a second. Now that all of our testing with our background variables is done, we'll need to execute the actual functions of them. And this one will be very simple. X plus equals horizontal speed. And then y plus equals vertical speed. These are very, very simple. Adds our horizontal speed to x, our x position. This one adds our vertical speed to y. And we should probably add in speed there. So, very simple. All of this, and yes, this is simple. This might look like a lot, but it's mostly because I've spent so much time talking about it and have all these comments in here. Compared to more advanced programming, this is the basics of the basics. First thing we do, we check our player input, we check our gravity, and then we check our collisions. All of these manipulate our speed variables. We start out by adding to them if we have inputs, then adding to our vertical speed if we have gravity, or saying, no, we're on the ground. Otherwise, we set them back to 0 if we'll run into a collision. After all these variables have been manipulated, then we actually move our positions. So, we're almost ready to test. We'll need a room, though, and we'll need to place our objects in here. So, start out. I made a couple of brick objects for us to use. Let's go ahead and paint ourselves a little floor along here. Enclose ourselves. No. We're not going to need that. Go ahead and add in a little vertical spot here. And that should be good. Now we'll start by placing our character object over here. And now, for the first time, please don't crash, we run our test. Simple enough. Here you see the screen for our game. I'm going to go ahead and get rid of the room in the background there so we don't have any confusion with the room we see on the editor versus the room we see in game. You can see I made a cute little brick texture for the wall. And then we have our rectangle, which we will manipulate. So, first test. Press A. We move to the left. Press D. We move to the right. Now, we did forget something, which is why we tested here. You'll see that he starts moving at actual constant speeds. That's because we didn't actually apply the friction. So now our little rectangle is running around on ice skates. We'll change that here in a moment, but the other thing we want to test is jumping. See if that will work. I'm currently mashing W, and our character's not jumping. So now we have to test what's going on with that. But at least the wall collisions work, even if they're a little inefficient. Now, go ahead and take a look at this. Watch very closely. In fact, I'll actually zoom in on this. Zoom in here. And here. Now, I'm going to accelerate to that wall on the right. Watch how he collides with it. You'll see how he sort of stops right before he hits it, right? He doesn't immediately bump into the wall. He slows down. And that's because we wrote bad code. Now I'm going to show you the better collision code here in a second, once I shrink this back down to size. And move it over here. Get this on the right. And there we go. There's the full window. So, testing is done. We're going back to our coding block. So, the first thing we noticed, our character is on ice skates. And our character can't even jump. So the first thing we're going to check. Now, what we are looking at here is our movement for keys being pressed. If we're pressing A, we want to move left. If we're pressing D, we want to move right. But if we're pressing neither, we want to slow down. In this case, we actually can revise our code here. So, if keyboard check, if A, then we subtract. Otherwise, we check for D and then move right. But we can actually combine these into a single block. So now we put an else if here. Meaning if we're holding A, then do this. If we're not holding A, then check D. And then we'll move right. Now, what if we're not pressing either? This is where we add in another else. And we don't need any other conditions here. So, this is where we apply friction if we're not holding any of our movement keys. In this case, we want to check if horizontal speed is less than 0, if we're moving left. Go ahead and comment that in here. If we're moving left, then we want to add our horizontal friction to our horizontal speed. So if we're moving left, we want to add to it. We want to add to a negative number to move it closer to 0. And then, again, if horizontal speed is greater than 0, we'll do the opposite. Horizontal speed minus equals horizontal friction. So, if we're moving right, then we want to subtract our friction and make him move more left, closer to 0. So, go ahead and test that out real quick. And there we go. We have our character moving, and you'll see that he slowly comes to a stop. And that's not me hitting extra keys, that is me releasing keys. So yeah, now our character is a little slippery, but he does slow down if we release our keys. And now, we want to go ahead and make him less slippery. So you'll see we have horizontal friction here that we use as a constant. Now, the reason why you have all these constant variables is if we just typed in numbers here, say 1 or whatever, if we ever wanted to change them, we'd have to update them every single time. What we can do instead here is change our horizontal friction to, say, 1, and that will change every other instance it's called. So now we have doubled our horizontal friction, which means we will both accelerate faster, but also decelerate faster. And we still can't jump. So now we've gotten our horizontal movement started, at least. Now we need to mess with our testing for jumping to make sure this works. So now we need to figure out why this part isn't working. If keyboard check press W and grounded is true, then jump. If there is a spot below us, if there is a wall below us, then right. Now, here's where our culprit is. So, right here, we check if we are on the ground and if W is pressed, which will set our speed to negative. This is why our jumping doesn't work. We are checking if there's an object below us, and if there is, then we set vertical speed to 0. Like how we read, the computer will go through every line of code in this from top to bottom. So the order that you write your code matters. Here we set our vertical speed to negative. And then after we tell our character to jump, we are looking below us if there is an object on the ground. And then we're setting our vertical speed to 0. So what we can do here is move this code around to check things. Now I'll want to think, where should we do our gravity amidst all of our other testing? What happens, and the reason why we don't jump, is our vertical speed is overridden by our gravity check here. So we can actually manipulate our bits of code, but since we have these collisions to deal with, we can sort of consolidate this stuff. Let's go ahead and move our gravity here to the top. Since gravity is one of the most important and central functions, you can generally have it be manipulated at the beginning. Now, it's going to check if there's a wall below us, and then set our speed to 0. And then after that check is made, then we'll be able to check if we can jump. So now that we've made that change, we can go ahead and see if we're capable of jumping here. And as pathetic of a little hop as that is nonetheless a jump. We can't get over this wall here. We can only get over something, say, 1 block high. So now we have to manipulate our variable here. Let's actually go ahead and lower our max speed to, say, 3. And now we change our jump speed. Now, for those of you who haven't taken calculus class, there's a little trick here. Doubling our jump speed does not necessarily double our jump height. It changes our velocity that we jump off with. And then our speed gradually decreases due to our gravity over time. So, just to show you here, if we set our jump speed to -20, which is twice of what it was, that does not necessarily correlate to jumping twice as high. In fact, we jump now 4 blocks high. And you'll learn that when you take calculus. Essentially, the very first frame we're jumping off with a speed of -20, and then that speed is going to decrease by our gravity every frame. So we don't actually want something twice the amount of -10. We want something slightly larger. Let's go ahead and break even with, say, -15. This should give us roughly, let's say, slightly higher than 2 blocks of a jump speed. And manipulating these numbers at the start of making your game is the important part of getting your character to feel right. With platformers, and generally with every game that requires you controlling a player character's movement, you need to have your character feel right as they move. So yeah, there we go. Slightly higher than 2 blocks. We can jump up here. We can jump off. Ah, that explains why our character is moving so fast. So, let's go ahead and look back at here again. You remember this guy, right? The little caution sign. Move speed is only referenced once. Now we get to the next part. You'll see how we're quickly sliding off, and in fact, we went off the screen and now our character's falling into the infinite void below because we did not put a wall on that side. We need, unfortunately we are not Sonic the Hedgehog, to cap our speed. Here's where we make the next check. We go back over here to the block where we are changing our speed. And we will add one more check here. If keyboard check or A and horizontal speed is greater than negative move speed. Right, that was the variable, right? Or was it mob speed? Right, we abbreviated it to MOV speed. So what this does, this is already better than most mobile games. I mean, it's bare bones, but, I mean, I guess I don't have any witty thing to say about how much I hate mobile games right now. But funny enough, I actually, I'd say it was 6 weeks ago, I uninstalled my last gacha game and haven't played them since. So, progress for Xander. Do a little bit of a round of applause there. Oh. I hit my key and that actually typed in a bit of code. So, if keyboard check ORD and our horizontal speed is greater than the negative of our move speed, you'll know that our movement speed cap here that we have, let's move that actually back up to 5 because we were going past that. So that is a positive number. We are wanting to test if we are moving not as fast as the negative version of it. Again, negative if we're moving left, positive if we're moving right. So what this little block checks is if we are moving left, but we're not as fast as our leftwards movement cap, then we accelerate towards the left. We'll do the same thing again here. If our horizontal speed is less than, I said, less than our positive movement speed. So this means if we are less than our horizontal speed cap moving right. Now, go ahead and run our game. Okay, that's weird. Right, I think it's actually the way that we've manipulated these functions. Hold on. So hit A, move left, and then for some reason we're continuing to accelerate left. So again, oh, right. I think it has to do with all of our inefficient use of else's here. I was actually holding D, and funny enough, that made me start moving left. So now you have to test that. Maybe if... I think it has to do with the else block here. I didn't actually anticipate this, so now we'll have to think and debug here. And horizontal speed is greater than our negative move speed. And horizontal speed. Okay, so it's only these blocks that are actually being checked. Since we actually don't know what's going on here, we can run the game in debug mode, which I wasn't expecting to be having to do yet. Yeah. Oh, great. Because of all the extra security checks we might have had to do, I might not actually save this VOD. Because I think it might have actually shown a bit of a security warning there for some things. I might do a revised version of this lesson for number 2. So we see why we're moving left. And this is actually, I'll have to give an instruction on debug mode later. But this is where we can actually tell it to watch for certain variables. Say, I already forgot how to make it check for the specific move speed here. We can, however, go ahead and put a block in here. There we go. Put a little red marker here, and when we enter debug mode, it will stop the game whenever it comes to this block of code. And then we can go ahead and hit play, but it'll stop us immediately again because it's running back over to this code. So now what we want to test is if we're holding right, if it passes by this block again. It does. So I guess that means that whenever we are holding D, it is coming back to this block of code at some point, which is wrong. But ultimately, that's because essentially I have written bad code here. So while this should be absolutely simple and readable to a novice, we might actually just have to throw away this entire block and start again. So I'm not going to spend the time to figure this one out just yet. Instead, I'm going to comment this one out. And now, you'll see we have this whole block here. we're going to condense this down to a smaller number of lines using some fancier math. So here we'll say horizontal speed plus equals negative keyboard check. We'll go ahead and just copy these here. A negative keyboard check ord A plus keyboard check ord D. This is a really weird little block of code, isn't it? Oh, wait. I forgot a parenthesis, it looks like. No, we have this one here that we needed to add. There we go. And that error should go away, right? Ah, we were missing a parenthesis here. And this is why we have those highlighted parentheses that we want to be able to check. So we use this to check on both sides of the block and make sure that every parenthesis is in the correct spot. So, here's an interesting little look at Boolean operators here. This line right here is all four of these lines condensed into one. So what we are doing is our keyboard check here, ord A. You remember our little look at the ord function here and how as we put in A, it's actually just telling the computer to look for 0041, right? Well, this whole block right here, the orange thing, is a function. And what this does is it actually tells computer a 0 or a 1 depending on if this input is true. So in this case, say if we're holding A, then this little block actually tells the computer, hey, 1 here. And since we have the negative there, we have the negative applied to it. And I'll actually teach the significance of that in a moment here. If we're holding A, it is 1. If we are not holding A, then essentially this values out to 0. Negative 0, which is also just positive 0. It's just 0. If we're not holding A, 0. Now we add that to the positive version of D here, which, same thing. If we're holding D, this is 1. If we're not holding D, it's 0. We'll take this block and multiply it by H friction. What this is it's these entire 4 blocks condensed down into 1. With these little functions here, we don't necessarily have to use them as part of if blocks. We only use if blocks if we want to test for a whole bunch of things and then have an entire bracket of code afterwards. Here, we are essentially condensing down the ifs into one efficient line of code. If we're holding A, the green text does nothing. Green text is a comment, meaning it is for us to read, and these are not actually read by the computer whatsoever. When the code is compiled for the game, it passes over all of these completely. These are for us to look at, and for us to take notes about the progress we've made. So, our horizontal speed will add -1 if we're holding A, or +1 if we're holding D, multiplied by our H friction. If we are holding A and not holding D, then this is 1 and this is 0. So, -1. If we are not holding A and we are holding D, then this is 1 and this is 0. So we get a 1 out of this entire bracket. This is sort of coming back to algebra, which, if you plan on doing any programming, you will need to know your algebra. And calculus can help, but algebra is the most important part of that. So that's if we're holding one key or the other. But if we are holding neither key, then they're both 0 and our speed doesn't change. Or if we are holding down both keys at once, they're both 1, and -1 and 1 together add to 0. So, in one line here, we have handled 4 different cases. If we're holding A and not D, or if we're holding D and not A, if we're holding both keys, or if we're holding no keys. Now, we do want to add back in the friction, because in this case, we didn't actually make ourselves slow down if we start moving. We can bring this back here, and right, left, and again, we've taken the friction back out. So now we can try to condense that down into one line of code, or we can just write another little line of code here. If this whole block is 0, then we'll do another little condensed line here for our friction. This one for moving, and this one for slowing down. So, if either we're pressing both keys or if we're pressing neither key, then we do this silly little function here. Horizontal speed minus equals the absolute value of our horizontal speed times h friction. Now, that's a wild little block of code, isn't it? This is the first thing we'll need to understand. ABS, absolute value, which essentially just means if it's negative, make it a positive. This function returns the absolute value of the input argument, so it's a positive value, then it will remain the same. But if it's negative, it will be multiplied by -1 to make it positive. And then we have the minus before it. So essentially what this does is, if our horizontal speed is positive, it subtracts our positive speed multiplied by our h friction. And essentially, if we are moving right, then it just subtracts our friction from it. If we are moving left, wait a minute. No, I think I got this backwards. Horizontal speed plus negative. No, I think we had it right. No? I might have got this backwards. Good thing we're waiting on Siphon then, since I think I might have actually gotten this wrong. Let's go ahead and plus equals negative. Let's just at least test that out. That should be slowing down unless I got that code in the wrong order. Yeah, moving right works, but what about moving left? Yeah, worst case scenario, we continue accelerating left. Right, this wasn't where we use ABS. ABS was actually where we use the maximum speed check, which was part of the block right here. Yeah, okay. That's where we actually use the ABS. ABS isn't what we use here. It's sign, which checks the sign of the number. If it's positive, it's positive. If it's negative, it's -1. That should be the right function. Right, I got it backwards. So simple enough. Welcome back, Siphon. What this does is this is our horizontal friction right here. Now let's go ahead and condense this back down to minus and then the positive sign there. So, if we're moving left, it subtracts a negative and essentially adds a horizontal friction. If we're moving right, it subtracts a positive and makes us move left. So that's what our friction is here. Left and then slow down, right and then slow down again. Now we'll need to implement back in our we'll need to implement back in our speed, our maximum speed. And then we'll do if, and this is where we actually use ABS again, if the absolute value of our horizontal speed is greater than our move speed, this accounts for both moving left or moving right, because the absolute value here. If we're moving left, it will change this check to be positive. So essentially this means if we're moving faster than our allocated maximum speed, HSB equals move speed times the sign of HSB. This just means set it to the cap if we're moving faster than what we're allowed in both left or right. So now we shouldn't accelerate like mad. Yeah, there we go. We have a nice, cozy, slow maximum speed. And our character's moving again. Jump up there, jump off there, and continue. Of course, if we go off to the right, we just fall off the screen entirely. We can actually condense these lines even further, but I'm going to move on from there. We've at least gotten the friction down correctly, using some more condensed and proper code that accounts for both the cases of moving left and right. All this up here, what is this? It's essentially 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that's 8 lines of code condensed down into 5, and we can condense that further. But we'll move on from there. One thing you did notice, and it's subtle now that we're moving at a slower speed, and that is our collisions with the wall still are a little imperfect. We've refined our movement code. Our gravity and jumping code seems to be just fine. This can stay the same. What we want to manipulate now is our collisions. This part of the code we basically never have to change. Or if we do really complex functions, we can change this in the future. So, you saw how we condensed this down into this. All of this, we actually need more code to handle the weird corner case here. Let's see if I can, let's go ahead and raise that speed back up to 10 or so. And watch closely. I'm going to demonstrate one more time. You'll see there's a little pause right before he hits the wall. That he kind of slows down and then he collides. This here is bad code we need to change. Since we have speed that changes, our collision testing needs to change to account for it. Now, we get to introduce you to for loops, which is basically a question that handles things step by step. The if here for horizontal speed gets to stay the same. But this we are going ahead and comment out, and in this case you use slash asterisk and then asterisk slash, and with that we've turned this entire block into a comment. This is no longer going to be read by the engine. So, Now we have an interesting little thing to do here. For loop. And this is something that you can use if you want to test something multiple times or handle something multiple times. This is a loop, which there's multiple ways to get into multiple different ways to get into loops. For there's also while. And what you do is you have a condition here, and then while that condition is true, it will run this entire block until the for loop here is false. I'm going to take this slow because this was a little confusing when I first read about it, but it should be able to be explained in enough time. For, let's say, coding standard is to use I as just some random variable that we create here. I'm going to go ahead and type it out and then explain it block by block. I is 0. I is less than absolute value of our horizontal speed, and then I plus plus. So this is what a proper for block looks like. That looks very confusing, and I'm actually going to show you why it isn't confusing at all. Are they commas in this game, or are they should be semicolons, right? Yeah, that one throws us an error. Welcome, Crimson. We are working in Game Maker Studio, which is mostly comparable to C. Yeah, welcome, Crimson. We are just starting a little introduction to for loops. So, a for loop has 3 brackets to it. This is our starting condition. And then I'm going to go ahead and space this out over here. This is our end condition. And then this is our iteration. This happens at the end of each loop. From what you know of the C programming language, I like C. Why am I catching hands? I like C. Let's go ahead and add a couple of spaces there, make this better aligned. And that's actually a short reason why we use I here. I stands for iteration. So, we want to run the block of code here multiple times. And to test for that, we use all the stuff here in the loop. Let's go ahead and move this back over here. Our starting condition. We have a variable that iterates, which we start with 0, since we haven't counted yet. We end it, or wait, no, that's not an end, that is an end condition. Or more accurately, it's sort of a while or during condition. So while this is true, while our iterative variable is less than our speed, once this is no longer true, we will exit this loop and exit this block of code. And then the iteration happens at the end of every time this block of code runs. Well, we haven't ran it yet. So, if, now we bring this back. If there is a place meeting, M and N are also good. I was just taught I, and yeah, from a lot of the calculus stuff I've seen, they've used M and N. M and N. I actually doesn't show up in pure math very often because it's used as a placeholder for the imaginary number or square root of -1. Programming is math, but in its own little environment. So a lot of folks will actually use I, and then if you need another one, we'll use J, and then K, and then L, so on and so forth. But you can use anything here, just as long as all 3 of these are the same. If there is an object in front of us, No. If there is not an object in front of us, then we will move forward 1. Else, HSP equals 0. And for courtesy, I think... No, actually, that should exit. Yeah, okay. So, what this does, if we can move 1 pixel right, then we move 1 pixel right. Otherwise, stop moving. And this whole block right here, I'm going to go ahead and move this curly brace over here for readability. That is a lot of stuff to go over, but this whole block right here, does everyone in the class understand this? What this does is... Oh, wait, that's testing for moving left. Let's change that back to moving right. So, if we are moving right, what this loop does is this essentially means repeat for every pixel we move. That's what the HSP is here for. This loop will repeat a maximum number of times as our horizontal speed, which is how far we'll be moving in a direction. So, first loop. We'll check and then we'll say we repeat this as many times as our speed. If our speed is 0, then we don't have to move. If place meeting, the exclamation point here means not, which is another part of the weird coding syntax here. The exclamation point is not, so if there is not a place meeting at this, you know what? Hold on. We can condense this to be 1 block. Yeah, okay, so change of plans. You saw that we had 2 separate blocks here for moving left and moving right, right? We can actually condense these into 1. And in fact, we aren't going to need these as part of it either. And go ahead and drop out the blocks here. There we go. So, like what we did with our horizontal movement speed, with this whole block right here, we are going to condense it down to 1 set of code, which handles both the cases for moving left and moving right. And that's why we have the absolute value here. Repeat for every pixel we move horizontally. And now we're actually going to change this +1 here. Plus sine of horizontal speed. X plus equals sine of HSP. Now, for a maximum number of times equal to our speed that we're moving for every pixel, the absolute value here means that if it's negative, we consider it positive for this question. So if our speed is currently 5, this code will repeat a maximum of 5 times. I starts here at 0, then we check. If there is a wall 1 pixel in the direction we are moving, that's what x plus sine here means. Sine is if it's negative or positive. If horizontal speed is negative, then it essentially means x minus 1, or 1 pixel to the left. If sine is positive, then it means 1 pixel to the right. Sine here just returns either -1 or +1, depending on if horizontal speed is negative or positive. So if that pixel is free, Then we move over to it. We move 1 pixel to the left or 1 pixel right. If it is otherwise occupied, though, then we change horizontal speed to 0. Every time it goes through this loop, it changes our X position by the distance you travel per frame, which is horizontal speed. Yes, horizontal speed is HSP. Every time you go through this loop, it will change your X position by your H speed. But what we have here is also a collision check with walls. So the reason why we're repeating this is to handle a little corner case. Previously, with our block of code here we just checked for if there was an object a certain distance away. Essentially, it just checked our speed and checked if the spot that we were trying to move into was occupied. Now what we're doing is we are essentially breaking it down into smaller pieces and moving it one by one. If we're, for example, I can use an example like this. Say our guy is trying to move over 32 pixels to the right. Well, he can do that. And then he can do that again, blah, 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 blah. Comes over to here, 32 pixels to the right, and then he can move. But then he says, okay, can I move 32 pixels to the right? No. So he doesn't do that. We're chopping it down into smaller increments to handle the case of, say, if he doesn't snap to a grid. Let's say, if he's trying to move over 128 spaces to the right. Well, he'll check over here and say, no. But if he's right here, and he checks for this position and then says he can't move over there, he's going to stop. But look at the little bit of space here. We can break it down into smaller bits. And for those of you who have watched Pan and Coax videos, you know how Mario checks his position at 4 steps every frame. What we're doing here is breaking it down bit by bit. So it checks, can I move over this much? Okay, yeah. Can I move over this much? Yeah. Can I move over this much? Yes. Can I move over this much? No. So we'll go back and we'll just stop here. And there will be a better explanation here in a moment. We can do the same here. We comment out this whole block, so this code no longer compiles. We're leaving this in here for future reference, and if we need to copy and paste from it, but it will no longer be handled by the game. This is horizontal collisions. Now, we get to do this for vertical collisions. And there's reasons why we handle them separately, which I can introduce you to later. We can use I again because the iterative variable here only exists for the duration of this loop. And then it's deleted. We'll do the same thing here, except we'll change all the HSPs to VSP and swap out the X and the Y. And I don't think we need to change anything else here. So let's go ahead and test it. Glued himself into the wall now, did he? Seems we got him stuck. And that is because I think we actually moved 1 extra pixel, and that was the issue. So let's start this with 1, just in case. I did write code similar to this that I did refine, and no. That actually makes it worse. That makes us able to move through walls 1 pixel at a time. So now we have to think. Our issue here might be in place meeting. So let's go ahead and take a look at the manual once more. What if you start at -1? Let's go ahead and give that a try, Dr. Cave. And welcome, by the way. Nope, still get stuck in the wall. And I think a part of that might be the place meeting part of the code. Really weird that we're having that. So, let's open up our manual again. Place meeting. With this function, you can check the position of a collision with another instance or all instances of an object using the collision mask, blah blah blah. Will work for precise collisions, but only if the instance and the object checked for have precision. Let's see here. Yeah, you see we basically have a similar check here, but it's a bit less efficient. Or it doesn't handle every corner case correctly. Please note that you should need to get the unique instance ID of the object being. Okay, instance place. Let's go ahead and check our directory of collisions here. Place empty or place free. Is that checking when they share a pixel and not when they are adjacent? So this should be able to check an adjacent pixel. For example, if we are moving right, then we check the sign. So the sign here means it's only going to check if we are moving left or right. So if HSP is positive, then we should essentially check 1 pixel to the right. I don't know why we go 1 extra pixel in. I might need to look at our other project. We'll definitely get through the beginning here before we test some of the other stuff going on. And I might actually have to break out my old Game Maker project and look at the code there to see what I've done here wrong. I think it might be that this right here checks at the beginning of the loop. That's an interesting idea there, Cave, but I think I actually have an idea. Instead, we'll go ahead and add a break here. You'll see that break here is orange, and what break means is we terminate the loop immediately. Now, the issue we might be having is when the for loop starts, it might read horizontal speed and then save that. It might not actually check this every pixel. What the break here does is it checks whatever loop we're in and then stops it right then and there if it comes across here. So, if we run into a wall, we set our speed to 0 and then stop this entire block of code altogether. Let's go ahead and give this a check. Nope, still getting stuck in the wall. That's interesting. Let's at least see if our jumping works. Jumping works just fine. Except now we've actually gotten stuck in a wall again. So you might be on to something, Cave. Let's think about this for a moment. So, welcome to the debugging part of the code. Right. This is our issue. I believe. And if this turns out to be actually be the issue, +0 and -0 will evaluate to the same, basically. That was it. That was it. Okay, so now our code works perfectly. So, the issue we had. All of this was right. But we still had this implemented here as moving our speed again at the end. I remember this because I was writing this code for when I was writing my own game project. Now make it do a behemoth typhoon. You know what, Zero? I have something special to show. I mean, I have basically two crowds here that I please to. And there's a little bit of overlap between them. I have mostly one crowd that's here for indie games, more relaxed things, and then one crowd that's here for fighting games and more complex things. Funny enough, I wasn't expecting there to see overlap. I was expecting my more casual crowd to show up here. But since you are here, Zero, as part of the crowd usually here for fighting games, I have a little thing to show you next time. And I'm not going to boot it up right now because it's on a different account. But I'm doing this from experience because I do have another game project started, one that I started a long time ago. And that actually is an engine that can interpret fighting game inputs. So I'd have to at least actually copy over that code from another account, but yes, indeed. In fact, by the next programming stream, I can indeed make something do a behemoth typhoon. Which might even, you know what, let's save it to, I don't know. I'll leave Saturday open as a gorilla option, but I'll definitely say I'll leave that in as something to check for the next programming stream. 2 EWGFs in a row. Congratulations! That's a very difficult input to do. Yeah, okay. I'll go ahead and break out the other engine that I was actually working on, which has better, more refined versions of this code, and actually show you a fighting game input interpreter. But that's for next stream. We're going over the fundamental basics here. So you see all the stuff that we had down here. Horizontal speed adding and collision checking, and we had them separated. Now we've condensed them into a single block here. All of this is the code that we've condensed it to, which ultimately, what do we have here? Like 20 lines? Where beforehand it was maybe 30 or so, and a little bit sloppy. In fact, there's even better ways we can handle this. But the issue we just had with landing inside of a wall was, here we have a position manipulation, and here a moment ago we had another position manipulation. Essentially, we accidentally made our character move twice. So when they came up to a wall, they checked their maximum movement speed but moved twice, essentially, and accidentally would move into the wall there. Because we did our position update twice. We have it here actually as part of our collision testing code. We don't want that to repeat twice, so now we have it only going through once. Go ahead and look at our little test here one more time. Here you have our character moving left and right. He has a maximum speed. He can jump up here on top of the platform, jump off, and continue moving. Everything here looks ship-shape and correct, right? So there we have for a beginning. To review, first thing we have here is a gravity check. Here, overall, we've mostly looked at collisions, variables, and constants. Here we have the constants of how our character moves. We can adjust these to change how our character moves regardless. Change that to a lower value. It changes every instance that it's tested for in the code. Now you'll see we accelerate and decelerate very slowly. Change that back to 1. These are our variables, which will change during the course of the game. We'll get to facing later, and that happens more when we have graphics to worry about. Grounded, we check if we are on the ground or not, and then we use that to check for our jumping. We've also tested inputs here, so essentially we've gone over 3 things. collision variables and inputs. Make sure to ask any of the questions that you might have as I'm going to go over each and every last bit of this code that we have running, one by one at a time. So, here's our gravity block. If there is something below us, y plus 1, again, positive y is down, negative y is up. If there is a spot 1 pixel below us that contains a wall, then we set our grounded to true and our vertical speed to 0, meaning we don't fall any further. If we're on the ground, gravity isn't acting on us, so set our vertical speed to 0. Otherwise, if the spot below us is open, we are in the air and grounded is false. And then we add our gravity to our vertical speed every single frame. Simple enough. Now, we did the easier, more novice version to read, but less efficient code up here, which I guess you can go back to the video and try to understand that, but that's why I left it there as a comment, where you can understand sort of a fundamental way of how it works. Down here, we've actually condensed it into a setting function. Horizontal speed. We add the input of if we're going left, or input if we're going right. Newton's third law, exactly. Exactly, it's Newton's third law. Oh, wait, no. Was it the first law that had the object in motion stays in motion? Right, no. That was the every action has an equal and opposite reaction, right? If we're on the ground, gravity isn't acting on us. Okay, let me change it there for our associate Dr. Cave. Thank you for catching me on that. Revise that to if we're on the ground, gravity isn't changing our speed. Does that work, Cave? Is that more correct? Gravity's still acting on us, but we don't actually have a spot to move forward. Yeah, I'll have to take a review of Newton's laws and remember which is which. Yeah, essentially Newton's third law is if we're on the ground, then the ground is pushing back on us equivalently with the amount that gravity is pushing down on us. After that little detour. Right. Horizontal speed checking. We add to our speed if we're pressing left versus if we're pressing right, multiplied by our horizontal friction. We can actually change that to an acceleration variable if we want us to speed up and slow down at different rates. But for a basic demonstration here, we're going to use the same amount for how much we speed up and how much we slow down. Then another check here. If we are not pressing either, essentially if we are not speeding up left or speeding up right, then to our horizontal speed, we add the negative sign of our friction. Essentially, this means slow down by the rate of our friction. And then this here, the last bit of our movement code. If we are going too fast, reduce us to our maximum speed. So there. Movement and input. Gravity, movement. Jumping here, if we press jump and we are on the ground, then we set our vertical speed to whatever our jump speed is, which is a negative value, and we jump off the ground. Vertical speed is now negative, we start going up. Then the last important block. Look at how clean that is. All of this mess we condensed down into just these two blocks right here. These two for loops. Collisions. For a maximum number of pixels, that is our speed. Basically, we break down the speed that we're moving, pixel by pixel. If there is a wall in the pixel that we want to move, or if the pixel that we want to move to is free, we move over 1 pixel. Otherwise, we tell ourselves to stop moving and then stop checking if we can move further. Break this code. Same thing with the vertical collision here. For the maximum amount equivalent to our speed, check if we can move down or up 1. If the spot above or below us is free, move over 1 pixel, and then repeat while we have I here less than the amount of our speed. This essentially puts a maximum cap on how many times we run this loop. If we never actually collide with a wall, then we just move over whatever our current speed is, that number of pixels. Otherwise, if we went into a wall, vertical speed is 0, break. And there it is. There is all the code that we're running. All this, these blocks, and these blocks. Very clean, very short, sweet, to the point, and simple for what is a little platformer engine. And there's a start, at least. Now, what we can do is we can manipulate stuff for extra jumps or adjusting speed. We can have different amounts of aerial movement, ground movement. We can have variable jumps. We can have one-way platforms. So now, for those of you who have stuck through to the end of the lecture, my question is, get me my wait, no. Let's not do Jelly Roman. Let's do the best font. So there's my question for you. I'm going to say that we are done coding for tonight. That is roughly a 2-hour demonstration. I said question mark. There we go. What do you want to cover next? We have a number of different options here. Siphon here did mention a double jump, which we have an easy check that we can do for that. Let's go ahead and add in another little space here. Double jump. Variable jump. Any of you that have played a lot of platformers know that you can change how high you jump depending on how long you press your jumping button. Is there anything else you guys would actually like to look at? Those would cover maybe an hour worth of a lesson. If you wanted me to, I could actually demonstrate the little bit of code I have for fighting game inputs, which I did do that on another engine, and if you are, yeah, Zero already said he'd attend, so let's mark that down for some stream in the future. I guess we can go ahead and do that. That should cover 2 hours or maybe even 3 hours of content. Dash. There we go. Let's just make this font a bit smaller so that we can fit more of it on here. Dash. Which is another input we can test for. And that's actually something I've done on my little fighting game engine I wrote. So it's a cool little thing for us to do. And there's several different ways we can do it. Yeah. So let's essentially consolidate it down to make these lines smaller for me, please. Shh. Ooh, mint. There we go. That's our focus for the next lesson. Movement and inputs, which the inputs aren't necessary for a fighting game stream. But Zero had made the Behemoth Typhoon joke, and so what we're doing here is essentially arrays and strings. And I can show you the cool little way we've done that interpretation. I think that will make for a very wonderful lesson next time. Maybe this Saturday, maybe next Saturday. I might take the extra time to go ahead and prepare a longer, better lesson. That is a lot of speaking done for tonight. I do believe that should be every. Oh, wait. Yeah, fighting game inputs. Go ahead and leave that out there. Sounds like an excellent little thing for us to cover next time, right? Any last questions or recommendations or additions? Otherwise, now I have to think what games we'll be playing this week. Yeah, I'll definitely have to call it Schmovement for the next stream. Good night, Kayla. Thank you so much for your attendance. Yeah, that should be everything done then. If that's the case, bring you back over here, and I'm scooch over to the side here. We had a really big week last week, and this week I'm still not sure what to do. So I'll go ahead and make it a bit of a variety stream. Probably no more King of Fighters. This week, I'm going to go ahead and need to get in a lot of practice and figuring out which teams I want. But it seems to be really popular on Twitch, so we might even pick it back up even if it's unpopular on the YouTube side. Good night, Siphon. Love you too. Otherwise, we'll probably just go ahead and let's see. Yeah, I can bring up my Steam window since I no longer have my screen being shared. Gonna be Strive on Friday again, as always, but maybe again earlier in the week. I'll go ahead and try to fill out the middle of the week with some other games, and since we have completed Inscription, I'd like to actually leave that to rest for now and move on to our next sequence of games. What did we do last week? Your channel. Go ahead and look at the subscriber. Let's see. We did Dead Cells. Yeah. It might be a lot of the same stuff. We did just get on the 4BC, so expect Oblivion, Dead Cells, and since we did finish Inscription, I'd like to start our next indie episodic game. So I'm thinking Everhood should be able to be cleared up in 1 or 2 streams. It's been out for about now maybe 3 streams. That game should be a lot shorter than Inscription, and we should be able to clear that up in a short amount of time. After that, I think we'll move on to Franbo. I'll go ahead and look at the Discord and see what all of our other little votes are for. But yeah, Hollow Knight will happen soon after, but I know Hollow Knight takes a while, doesn't it? Since we just did a very long indie game, I want to do a short break with Everhood. Then we can move on to Franbo and Hollow Knight, are 2 of the indie games that I have on the list next. But we also have some asks for Pokemon, which is a favorite of mine, and I might go ahead and start some Pokemon runs soon. Don't know if it's going to be the new ones or some of the older games. We'll go ahead and open up the discussion for that in Discord. But tonight's stream is one I've been looking forward to for a very, very long time, and I'm pleased with all the success that we've had so far. In fact, we might even get to return to Rivals of Aether sometime in the future, since that's something I've left behind a long time ago, but I've always wanted to get back to. Regardless, thank you everyone for your attendance. Good night to you all. Class, and in this case, a formal actual class, is dismissed. Good night, everyone, and thank you. Siphon, Kayla, Cave, Crimson, welcome to the channel. I don't believe I've seen your name before. Zero, Ajoy, Sochiel, Decursion, Harus, ETG, James, Natsume, Broham. I do believe that is everyone. Good night, and good morning, and good afternoon.